Здрасте.
Добрый день.
Здравствуйте.
Здрасте.
Здрасте.
Так.
Добрый день, слышно?
Да.
Да.
Да, тут, значит, у нас мы собирались устроить доклад некоторого товарища из Германии по поводу работ Бармпалиеса и этих самых омега-чисел Чейтина, но выяснилось, что, значит, наши те самые немецкие граждане, они как-то опасаются иметь дело с российскими организациями, а семинар зарегистрирован как бы считается семинаром при Московском университете. Ну, может, пора его перевести куда-нибудь, но это другой уже вопрос. Но, по крайней мере, значит, этот доклад откладывается, но так или иначе он состоится. Может быть, Вольфганг Меркли что-нибудь расскажет про это же, или Лоран Бьенвеню, или кто-нибудь еще.
Нет, в связи с этим у меня такой вопрос.
Да.
Если мы устроим этот семинар во Франции,
Да.
идеально во вторник, но можно и в другое время, и в другой день, смогут ли российские заинтересованные участники присоединиться? То есть такое стандартное время у нас...
Нет, еще проще было бы устроить его в понедельник.
Нет, ну, тогда, значит, нет, кому проще?
Нет, то так было бы более, так сказать, гладко, транзишн был бы проще.
Во вторник очень неудобно.
Очень неудобно. У нас такое стандартное время, правда, в это время давно никаких семинаров нет, уже месяца два. Это вторник, 12 часов московского времени.
Ну, нет, тоже неудобно. Я думаю, что мы не торопимся. Может быть, к сентябрю эти самые немцы пересмотрят свою точку зрения.
Нет, ну и тут я с вами не согласен. К сентябрю может все так пересмотреться, что уже там и докладывать будет нечему, и некому, и слушать некому. И вообще у тех, кто значит, останется в живых, они будут завидовать мертвым.
Нет, но дело в том, что Бьенвеню, этот самый, я имел в виду даже не немцев, а Бьенвеню. У Бьенвеню проблема, что у него в этом семестре по понедельникам занятия.
Да, нет, но он бы тоже мог рассказать про эти результаты, а в принципе...
Хорошо, а если не вторник, а среда, как вы на это смотрите?
Ну, мне лично подходит среда.
Даже не важно, будет ли это утром или там, в 12 или там в 15.
Мне не важно.
Не важно.
Ну, мне тоже не важно, ни в 12, ни в 15 я не смогу до конца семестра.
Ну вот.
Понятно. Вижу. Жалко. А есть ли какой-нибудь день недели, который москвичам удобен?
Ну,
Нет, а чем плохо прямо вот это же время, так сказать?
Вот, ну, я думаю, что в это же время у французских участников там какие-то там занятия в университете, и будет не очень хорошо назначать. Ну, можно организовать, не назначать наш обычный французский семинар,
Да,
а
организовать
организовать
специальный
новый.
Колмогоровский. Нет, я вот что думаю. Это было бы самое простое, очевидное решение.
Ну, особенно если его как-нибудь по-другому назвать, чтобы враги не догадались.
Почему? Зачем? Прямо так и назовем.
Ну, может быть, немецкие товарищи будут беспокоиться.
Нет, Колмогоров, немецкие товарищи никаких претензий не имеют.
Давайте мы назовем наш семинар «Групп де Travail», и все проблемы будут сняты, я думаю.
Вот, ну хорошо, ладно, значит, давайте это, я думаю, можно обсудить потом. Значит, сегодня мы должны заслушать разъяснение по поводу нашего, как это называется, машинного обучения. По возможности на примерах и это самое.
Да, вот я что-то писал эту презентацию, особо там примеров как-то...
Нет, но мы, может, прямо запустим какой-нибудь пример, и ты будешь комментировать в прямом эфире.
Да, а тут у нас Флорес присутствует, мы хотим говорить.
Yeah. If there are Russian examples, we cannot do anything. But if you want to say something in English, it's maybe it's feasible.
Well, I can talk in English, basically, definitely. Unfortunately, I prepared my slides in Russian, but
okay.
As usual. Forgetting the bad example.
No, since the examples will be probably some examples will be related to Russian also. Then
no, I believe examples.
Let's start and see how it works.
Okay. So let me try sharing my screen. I don't know how to do this. Should I play here and do you see something?
Yep.
Yeah.
And now?
Now also, and also not aber, but we see some kind of rectangles which mask something. Probably that's the messages of other windows in your screen.
Oh, that's interesting. I just play. Okay, let me.
There is what here there is a message.
To be honest, I don't understand what's happening. Maybe if I do this and then.
No, it's just what should happen with machine learning algorithms. You never understand what.
Yeah, you never know what happens. That's right. You're correct. Maybe if I share this part.
Yeah, but still there are strange rectangles. Okay. Oh, no. Now, okay, they disappear. They are moving. And
this is because I'm moving some zooms,
but we cannot
parts of Zoom's
messages at your screen, but we see rectangles that probably contain them.
Are they, obstructing much of the
large language models. Maxim Ушаков from Calibri AI, and this is some kind of startup with some strange name.
Yeah.
And strange owner and everything very strange. Okay.
Yeah. So last time we talked about large language models, but now as we are trying to speak about the more practical examples, I parenthesize the word large because, if there is a very large language model, you can't really use it for anything practical because it requires a lot of machines doing work in parallel, and it takes a lot of time to process a single sentence and has low throughput, etc. You cannot launch something like that in production. You have to cope with the smaller sizes of the language model. So the plan for today's talk is like this. We start with non-language models, with a image recognition, ImageNet, transfer learning, and what was happening before 2018 when there has been a some kind of revolution in natural language processing. Then we'll talk about the transformer models, about this transition, revolution of 2018. Then about a few examples of which models are currently used and how they are applied in practice. The first
image recognition.
Yeah, this is image recognition. Yeah, exactly. So it happened before all this language model work has really started. And actually that was the thing where the neural network revolution has started. The neural network revolution started from winning a contest on image recognition. Basically, you had one of these pictures, like, this is I don't really know what's that, because there is no car category in the data set. But anyway, this is a flag, this is a computer monitor, this is a plate, a cup, etc. There was a 1.2 million of pictures of this size. I believe it was like 240 by 240 or something pixels, belonging to 1,000 of categories, which was like sport car, collie, labrador, etc. For some reason, there was a lot of dog breeds, and unnaturally large number of dog breeds.
Excuse me, Maxim. These categories, they're disjoint.
Yes.
One picture.
Yes, they are disjoint. Yeah. Every picture belongs to exactly one of this.
No, was declared to be in one of this. So I guess.
Yeah, of course. Yeah. There were pictures that probably contain two of them, but most of them contain something like a single thing, or a single. This one is brick wall, right? It's not even the whole thing, but it's clearly one of the categories.
I would say that this is повернутая мостовая, but
yeah, maybe. Yeah. But this is a wall.
Yeah.
That was a very popular data set used in a very popular contest, even before the neural networks became so popular. And the first thing that everyone, the neural networks got everyone's attention when one of the neural network won this contest by a large margin. It was 2012, I think, with AlexNet. And from then, there were a lot of networks trained on these ImageNet data set, with different architectures, different ways of training them, improving quality more and more, etc. And so the next thing that was invented is that you can take a neural network trained on this ImageNet and fine-tune it to solve a different problem. For example, there was a TV series, Silicon Valley, where they trained a neural network to tell a hot dog image from not hot dog image. And this is called transfer learning, and it's performed like this. You have a large and very good network that is trained on ImageNet, on all those, more than 1 million images. You can train it yourself, or you can take a ready-made one, and then you get your smaller data set. For example, hot dogs or not hot dogs, which may consist of hundreds of images, or a small number of thousands of images, which is not enough to train a neural network from scratch. But you can take that network trained on ImageNet and fine-tune it, like by train it a bit more on this new smaller data set.
So fine-tuning means that we have the same parameters, but we just adapt them for this data set. So it's like
exactly that.
Yeah.
And this resulting network would perform better on the new data set than any network that you can train from scratch on that data set. So why is that? Nobody knows, of course, but probably, or you can find something. It's not truly understood, how it works, but it looks like that while training on ImageNet, some of the layers of the original network were trained to recognize different parts of images, like points, corners, lines, textures, a combination of points, lines, that are rectangles probably, etc. And that is very useful in training the new network. You don't need to train neurons to recognize all these corners, lines, and rectangles on the smaller hot dog data set.
But this somehow means that you should, does it mean that you change the parameters on the higher level, keeping them the same on the lower level of networks, or is it just what happens, but you don't plan for that, but this happens?
There are different regimes of training the smaller data set. You can freeze some of the lower layers that that are near the input, and only train the higher levels. This is one of the ideas that usually was.
So you can do both. It sounds reasonable.
Yeah, you can put different coefficients on the updates. You can update the lower levels less than you do on the upper levels, or you can just assume a smaller learning rate and just slowly change all the layers.
Yeah, one more quite common approach is to train on union, have a separate output for your particular problem, and having the same network trained on both original data set and your own with your own additional output.
So you mean that for this small input, just there is the problem is not that we don't have enough time, but just we don't have enough data. So if we do long learning on small input, it will give nonsense, but with large input is okay.
Yep. So there is an option to train to start with something close to the original problem and the original data set, and just have additional inputs in data set and add one more category to the original data set.
Yeah, and that quickly became the default method of doing the any kind of computer vision work. Actually, you design a very large, and complex, probably network architecture, but it usually contains, in some place or another, a part of network that was trained on ImageNet, and you start from that, or you even, in some places, you can you even just put it in there as a fixed module with no training. But it became the default thing. You take the ImageNet network and you fine-tune it, or train a bit more on your smaller data set, and then you get a very good quality. And for a long time, there was no similar thing in natural language processing when you have texts, not images, until 2018.
But before we go to text,
Yeah.
I just a question about some general question. So there are some natural problems, and I will practical problems. I will say what are the problems, and you will say whether machine learning is reasonable at all. What do you think? How it could be used or not? And what are the possible approaches that you would try?
Okay. Are you talking about computer vision or text?
Oh, both, and not
okay.
only. So, for example, computer vision. So I remember that when Misha Degtyaryov told me that you should recognize the letters in text, separate the background and the image in deja vu things, and to classify the letters, one should start with machine learning approaches and do something many times with many parameters and then change the parameters. And at that time I thought that it would be stupid and it would not work and so on. But it seems that now people are less more in favor of this. So for example, if you just want like Abby makes this fine reader and they do this without any machine learning. So if they would do it now, they would do it with machine learning, or it's not the type of the problems where it could work.
You mean the optical character recognition?
Yeah, optical character recognition, or at least separating the background and separating the letters as you need for deja vu.
Well, separating the letters from the background maybe, I think, done by various methods, because letters usually have sharp
but if you have
outlines, but the background
smartphone picture, then probably it's not that sharp. Yeah, and
yeah, right. I do believe that Abby Fine Reader currently uses neural networks.
But in general, you think it could
moreover,
be
I believe they used my neural networks even before it was cool.
But what was with the training set then? You should print a lot of pages and make not sharp pictures and try them, or what? Or you should
I think most of the blurriness and bad quality of scanned pictures is actually quite easy to fake without printing and rescanning it.
Oh, so you can
just
make
take
some synthetic
images
and train of them.
Yes, you can take synthetic data set, make synthetic data set and train on it. If you are lucky
and
enough
this looks reasonable to you.
Yes, more than that.
Okay,
yeah.
Another
if
example.
You're lucky enough to to guess most of the usual distortions that the scanned image has, then you'll get very good quality.
Another example, you have formulas and you want to convert them to text expressions. Would it be reasonable to use machine learning here? No, you want to retype mathematical books. You have a reasonable quality scan, so and then you can probably even recognize the 6 characters. But then you want to convert formula to text expression.
I believe there are 2 approaches that are viable in this task. They are the same in the first stage and they are different in the second stage. The first stage is you have to train a neural network that, given an image, understands which mathematical symbol is written in which place on it. Probably with maybe with even with dividing them into lines or matrices or something, so that the neural network would decide that these 2 images, these 2 characters are placed on the same height in the formula. And then there are 2 approaches. First, would take this input and try to guess a mathematical tech formula that produces the same characters in the same positions. That could be done in a classic algorithmic sense by understanding which delimiter corresponds to which delimiter, which is what is the subscript
Yeah,
for
yeah.
what
So this is
variable,
not
etc.
a machine learning task, you say. And from starting
That
from
could be-
this, you
that
start
could-
machine learning.
Yeah, this could be, the stage 2 could be non-machine learned at all, but it also could be machine learned, because what neural networks are very good at is detecting patterns, which probably could make a bit better quality when you see, you know, some complex formulas that, you know, a human would definitely understand that this, you know, parentheses correspond to that parenthesis. But the classic algorithm may start, you know, making mistakes.
But how you learn this? So you have this, just the Czech expression, and then you have list of positions where is where, which symbol is where, and then you have millions of these pairs, and then you just start general machine learning algorithm and see what happens. That's
No, I don't think that would be an interesting thing. I think a first stage of this, you know, stage 2A of that processing should output a series of rectangles that delimit the formula subparts. Basically, if it would be something
without
like x n over y n. No, it could be a neural network.
Mm-hmm.
If you have, you know, x n over y n, then
and you use it for
one
synthetic.
rectangle should have, you know, the numerator and denominator. The other should be a subscript. Or
Yeah.
something like that.
So you construct, you make a synthetic images using tech, and then you know the real correct answer for these rectangles, and then you're trying to learn.
And you add some noise to positions, so that it doesn't, you know, trick the network.
Okay, another, you have a recording of a music and you want to restore the score, or even better, to write a MIDI file which can be played on a modern electronic piano of high quality to produce the equivalent of this interpretation. Just for old recordings, you want to make their modern versions. Would it be reasonable to use?
I think it would be reasonable, again, to use neural network to convert the audio file or spectrogram, rather, to a series of notes and instruments. Basically, that it should output in each frame, it should output then, you know, oboe is playing C here or something like that. And that's easily, you know, such a data set can be easily constructed synthetically. And then I think another neural network could write the score. From
MIDI file, so to say.
No, not quite MIDI file. The first one would, or maybe yes, maybe.
Oh boy, see that at that time it's MIDI file,
Basically, yes, and then you have to write the score by, you know, finding the how do you call it? The measure.
The bars.
Boundaries.
You need to find the bars. You need to find the division between instruments and so on.
And it would not be, you know, easily readable after that.
But what I conclude from what you are saying, that these tasks are somehow different. You should not use some general library and just apply it to these images or music or whatever, don't taking care about what is happening and hoping that automatically things will be good. Just because what colleague Grigoryev said last time, that somehow mystically you have some very universal device which you can feed with almost everything and get something reasonable. A bit like the tiny classification of everything by compression. So you don't need to see whether it's music or audio or images or paintings or photos or I don't know what, and still you get something reasonable. But what you say now is not that.
No, not that. Yeah, that is a very recent paper, and I'm not sure it can be applied actually. Well, it's not too popular yet. It's not. Its usefulness is not proven by actual applications.
Okay. Yeah. In the so-called real world, yeah. Let's continue then.
Okay, so before we get into the the revolution of language models, I wanted to talk about transformers. So what was before that for texts? For texts, every neural network was an LSTM, basically. This is a recurrent network, which is computed from left to right, or you can compute it from right to left if you want. Basically, I do have a pointer. So you get the first word or character or subword, anything, unit of text. You compute the first unit of LSTM, then it outputs the hidden state to the next unit, and the next unit takes the next word and output from the previous stage and outputs the hidden state for the next unit, etc. You go from this end to this end, and at each stage you can output something.
That's what is called finite automaton with output, or transducer.
Well, it's not finite. Everything that is passed through these arrows is actually vectors in R to the nth.
Okay, yeah.
Even this thing is a vector actually. Then this architecture, of course, can only propagate the information from the start of the sentence to the end of the sentence. You cannot, at the word cat, you don't know what happens next. So people started using bidirectional LSTMs that gets this way and another layer that gets that way. And then you combine the output of the two, and then you have the information from both sides of the sequence. And then people started using multi-layer LSTMs.
And all this is somehow learned, or what you mean that the parameters of all these small white rectangles have to be optimized by learning, starting from something just a random point and trying to maximize the output.
Yeah, you have to understand that in the same layer, the weights inside these boxes are the same. All of these boxes are the same. Yeah, because otherwise you cannot do infinite, not infinite of course, but varied length sequences.
Yeah. So
okay,
but has the same rule at every stage. Yeah.
Exactly. Yes. But so what's wrong with this? If your sequences start to be long, then to compute this part, you have to wait for all these parts and all these parts to be computed.
Yeah, but
and then to compute this one, you have to wait for all the layer beneath it is computed on all the things on the left and right computed, which is slow. Well, which became to be a bottleneck of training the networks. At each point, you only can compute one or two places, and most of the enormous number of processors on your GPU are sitting idle, which is bad.
So it's not the bottlenecks for usage, but the bottlenecks for training, for learning.
For usage also, of course. But for training, it's, it's also very important, of course, because, you have to iterate a lot of times before you can get reasonable results. So on the other hand, the attention mechanism was invented. It was used for for automatic translation first, and then applied in several other places. The attention is a mechanism that can let one computation to look at an unspecified number of other computation results and take something that it needs from them, basically. And in its simplest form, it's formulated as this: if you take, these are the values that you should look at, and this is something that you want to compute. You can. So suppose all of these things are vectors. So the attention mechanism is computed like this: you take the dot product between your vector and all of these vectors. Then you normalize the resulting vector of numbers. In each place here you have a scalar. Yes, k1 dot ln, k2 dot ln, k3 dot ln, etc. Then you normalize so that sum to 1. It's usually done not by usual division by the sum, but via the softmax function instead, which first takes exponent from of all the numbers and then normalizes that.
But I understand the expression. So softmax of all wi is yes. Just one number. It's not an array.
No, it's an array. It's each.
So I in the left and the right hand side is the same.
Yeah, I should remove this. I think W is softmax of W tilde.
Mm-hmm. So it's just a number.
No, it's not a number. It's a vector. But these vectors sum to 1. The sum of all wi's will be 1.
No, so you take the scalar product of L and all k's.
Yes, and have 5 numbers.
Yeah, Max, looks like you have missed wi tilde divided by softmax.
No, unfortunately, softmax is not a maximum. It's not a function that takes an array and outputs a number.
Yeah.
Okay.
Instead, it's a function that takes basically takes an array of numbers, regards that as a logarithm of probabilities, and normalizes that probabilities.
Oh, yeah. So you just change.
You take exponent of each number, then you sum them, then you divide every exponent by the sum of exponents, and that is the output of sum.
And then you take a combination of this ki. So
yes,
if not the strange exponentiation, it was more or less will be computing a projection of our L to the space generated by k's.
Exactly. Yes.
But you somehow use this strange intermediate step with softmax. Okay.
It also introduces a nonlinearity, which is regarded a good thing in neural network.
Yeah. Okay. Yeah.
Okay. So this is very useful for example, a machine translation task. Here is the example of the softmax values of the translation from French to English or vice versa. I'm not sure. I've taken that from the internet. Don't judge me too harsh. But we see that the accord is agreement, sur is on, la is, corresponds to there, and then zone économique européenne corresponds to European economic area, which is in the opposite order, etc. And all that. It's interesting that this dot, for some reason, attends to this, was signed in August. I'm not sure why.
Yeah, but I don't understand. So how do you compute these values? You convert every word to some vector, and then you take a scalar product of the vectors.
Not quite. No, you have a neural network that an LSTM basically that takes these words, convert them to. You convert this. No, sorry.
So we have two networks. One works with English, and another with French, or what?
You take these words. So, for example, if you're translating from French to English, you take the French words. You take these French words, you convert them to vectors, and you run an LSTM over them that processes them somehow, including seeing what's on the left, seeing what's on the right, etc. Then these LSTMs produce a set of vectors that is an embedding of these words and sentence, including some of the context.
Okay, so you take the left column as l'accord sur la zone économique as input, and you don't have yet the English text as input.
Exactly.
So you make something with this neural network and French text.
Exactly, and you get a sequence of vectors which somehow encode the whole sentence in French.
So
basically, the first vector, the second vector would encode the word accord in this context, with the taking into account every other word in the sentence, and then you construct a decoder for that, which is probably another LSTM, a single directional, that given usually it's done like that. The decoder is given the prefix of the English sentence, and it should guess the next word for it. And in guessing that next word, it can attend or look at all these vectors, and when it does so, it produces this column of weights as a sub, output.
No, but we don't know that the next word will be economic. I don't understand. So we have the agreement on there.
And then you have the agreement on there. And you have all the vectors from this French side. So
how we know what we should select European?
Because you know that the next word here would be European.
No, the next word here will be zone.
Nope. You can usually using the attention mechanism. You're not saying, give me the fifth word. You're saying, give me something that looks like this, and you create a vector for that.
No, so okay, so you have the result of processing of the entire French sentence, Yes. And also you have the word the agreement on there.
Yes.
And somehow you need to find the next word which turns out to be European.
Yes.
How do you do this? Say it again.
You get.
So we have four English words and all French words.
Yes.
So
not words. Not words,
but transform it to
pre-processed sentence. In the sequence of vectors.
Yeah.
And you ask for this sequence of vectors, what should be, let me reformulate it. You ask that number, you have this bag of vectors, actually. You don't have any order on them.
Yeah.
And the order is somehow becomes encoded in the vectors themselves.
Yeah.
So basically you should ask something that after the agreement on what should be, what is we talking about?
So we are looking at some abstract array of expectations, vector representing expectations, and also the vectors representing all the words, and see which one is better.
Yeah, basically.
And
like
how
that.
do we train all this? Okay.
Well, it's trained in the usual way. You get the input sentence, the output sentence, and you take the prefix of output sentence and say, train it on the condition that the next word should be this. And then it's all somehow, train something,
Okay.
which we don't know how.
For me, it still looks like a mystery, but okay.
It is. It
can
definitely
believe for
is.
a while.
It definitely is.
Yeah, Max, the question is, how do you rotate your space in a way that vectors for French words and English words is the same space, not like two different spaces of the same size? Because if you're trying to take you're trying to take maximum over Scala project. So you need
no. We don't.
You
we
have
don't
to
need
map
to
French and English words in the same space, otherwise the product doesn't make sense. That's what.
Sense. Yeah.
Yeah, but not no. Yes and no. Of course, at some point when we query the attention module, we are providing the vectors that should be in the same space as the vector on the French side.
Yeah.
On the other hand, after that, we also do some processing with another layer of LSTM or something like that, which decouples that, and the vectors should not correspond to any English words. But of course, something is done, is trained inside that places the embeddings of something French and something English in the same space. And this is the one of the interesting results of that.
Okay, there is a question. I still don't understand. If the model generates nth English word given all French words and the first n-1 English words, how is attention used?
It is used as an intermediate step in the processing. You generate
maybe
some vector.
You should try to answer in Russian, because I think what's it easy?
No, that won't help.
Okay.
I assure you.
Yeah. Okay.
It's just really not really known.
Okay, let's go to some other examples. This is a bit confusing, but okay.
So the transformer, which is a paper of Ashish Vaswani of 2017, is an architecture of neural network that basically consists only of attention modules. And as such, it can be trained quicker than LSTM module by parallelizing the computations a lot more. And for some reason,
then the order of inputs tokens is taken into account?
Oh yeah, this is a very interesting question.
Yeah.
The original paper used what they call the positional encodings, which was a vector of some, I don't remember, like 512 real numbers that was in the ith position was a sine of pi times I times something like position number or something like that. So basically, each of the component of the vector was a sinusoid with a increasing frequency from the frequency of 1/512 to the frequency of 2, I think. I mean, two positions of text. Later, more contemporary networks actually use just trained positional embeddings, which basically you have like 512 different vectors, and you train them, which allows only for 512 different, the input length should be less than 512. But, you can, at train time, you can set that for whatever you need. And that's actually a very interesting problem.
Okay, it's also very confusing, but maybe we should go and see what you are doing and how. Yeah.
So we don't look at self-attention.
No, just say something at self-attention. If
self-attention is basically when you at each layer you attend to the values produced by the same layer. For that, you produce usually the key value and query vectors, and then you compute the attention weights using your query and all the keys, and then use that ways to sum all the values to pass on to the next layer.
Okay.
Don't ask me why it works, because nobody knows, okay. Of course, but somehow it works.
Yeah. Okay.
So the ImageNet moment in NLP happened using these basically 4 ground laying papers, when people understood that when training a language model on a very large corpus of texts, you train something like the representations the ImageNet networks learned in their lower layers, like corners, lines, and textures. You can learn some detectors for natural language features by using the language by training the language model. And what usually is understood by the term language model is something that can predict the missing words in the text. The simplest thing is that given the prefix of the text, guess the next word, or guess the probability distribution among the following words. But that's not, for example, BERT doesn't use that, and it uses a different thing. So what happened here? So this was LSTM, but already they trained a language model and then used embedding from that to be used in different other tasks, like, what are the usual tasks for NLP? Right? Guess the number of stars of an Amazon product review given its text, for example, or a movie review, or answer a question, or select the correct answers given the paragraph of text and the question about this paragraph, or something like that. There is a standard data set which was created, I think, together with GPT model or something, that combines a few of such standard NLP tasks of different nature, like question answering, movie reviews, guessing. There was something like entailment, where you get a question, a sentence and another sentence, and you have to understand whether the next sentence can be, contradicts the first sentence or entails it. And some other natural language tasks. So this one is just the embeddings for using the language model. This one is a very complicated scheme for fine-tuning the language model for solving these smaller tasks. And these ones, it's also used LSTM, yes? And these ones use transformers, and probably that is the reason why they are very easily fine-tuned for the smaller tasks. You get the language model trained on, enormous amounts of text. Not predicting
the missing words.
The GPT predicts the next word. BERT predicts a masked word, basically. You have a sentence and you mask one word and you have to reconstruct it, or probably more than one word. The main difference between GPT and BERT is that GPT is one way. It can only look at the start of the sentence while it's thinking about the next word. Yeah, and BERT can look at all the surrounding words, which makes it better if you don't need the actual language modeling thing. But you have if you need something like, I don't know, guess the review rating given the review text, you have to look at the whole text to judge what is the rating. So BERT is more suited for situations where you have the whole sentence available or whole text available.
Yeah, again, a question in chat. What about GPT articles that show that with really large model, you don't even need to fine tune?
That's not 2018. That's not 2018. That's much more contemporary work.
Okay. Let's move then.
I can tell. Currently, a very large model can be used in what is called zero-shot training, where it's so knowledgeable, I would say, that you can simply ask it a question like, what is, if you input the text into that model, that what is the review rating for this review column? This movie is very bad, ? And you ask the model to continue this this text, and the model is so large and so good at continuing the text that it would output the output like 5 stars. But that only applies to very large models that cannot be used in actual народное хозяйство, because you have to have too much resources to just run it. And I don't even start on how much resources do you need to train it.
Народное хозяйство is production for proletarian masses.
Yes. So GPT, GPT-2 and GPT-3 just predict the distribution of next words. If you input the cat set on, it's usually the mat in all the examples, that the GPT would predict that the next word is the with a log probability of -0.78, with much lower probability.
So it's the distribution, logarithms of distribution.
That's log probabilities. These are actual numbers from the GPT-2 base model from from transformers package. Bert tries to recreate what was covered by the mask token. George Washington has much higher probability, not very much actually, than some other first names. But you can see that this is a top 4 predictions. And you can see that most of them, all of them are first names of people, last names of people, right?
Yeah.
But I'm not sure who are those Georges.
Yeah.
And why are they present?
And whether they are Georges or not. Okay.
Yeah. Well, I don't know that. Yeah. So there is another popular architecture which is called BART, which has the 2 parts. It has the input sentence, which is bidirectional like BERT, and then it generates an output sentence, word by word, as in GPT, which also may be useful for doing something like the machine translation seems to be the usual application for that architecture. So the practical examples.
Yeah, what did you do exactly?
Yes, and not only me.
Not only you, but
yeah. For starters, there are non-practical examples, but you can try some of them. So there is a Russian GPT-3 trained by Sberbank, available at this URL, which generated the Beethoven nonsense that was used.
But I have to say that I have no proof that it was it, because I try again and they give new things. So not such a fantastic one that they gave the first time.
Yeah, of course. There are lots of randomness in this, and you can get different continuations for the same prefix every time you click on the button. But still, it's usually that because the texts look like Russian or English. They are clearly on the same topic as the start, but their sense is usually eluding or non-existing. There is the second tool that's called Write with Transformer, is an editor. You type something, you press a tab button, and it completes the sentence for you. Sometimes it completes very interestingly. Sometimes it's even useful. You can select, a few of the models using for that. Then, if you have some corpus of texts, not very small, like hundreds or thousands of texts, then you can fine-tune the GPT-2 for generating texts like that. For example, I trained a generator for scripts of Star Trek episodes at some point that produces absolutely nonsensical, but absolutely readable and understandable scripts. It even contained the formatting that was used in the training corpus, like,
okay, let me again interrupt you with a practical question. Imagine I ask you to write a program, an application, which will add the article the in mathematical papers. That's always reviewer write when we send the paper. Reviewers usually write something that one should put several articles there, here and there. So, but they usually don't tell where to put them. So, is it something possible for such a model?
The only question is, where do you get the corpus of articles of papers that contain the articles there in correct places?
Okay, but we can use, I don't know, we can use it, I don't know, no, books by English authors. No,
Okay.
I think we
You
can
can
just
do
take the all authors with respectable names and then use them as
like
models.
Smith.
Yeah.
Okay.
Yeah. So
Um,
would it be easy, difficult, possible, impossible?
I think that would be possible. It won't get a very good quality because, you know, putting the English article is a creative work, not something that can be easily done. By the way, using books is not very good because, you know, papers, mathematical papers are very different, use very different words, grammar, etc.
No, I mean textbooks, like.
Yeah, textbooks would be okay. Yeah, archive articles probably would be also.
Yeah.
If you'll generate, you know, English text on par with the average archive article.
What else do you need? Okay.
Yeah, I think. Yeah. I would say no reviewer can be more knowledgeable than that.
Yeah.
Then you can remove all the articles from the text and ask somebody, some model like BERT, at each point to tell whether before that point should be an article.
Yeah, so you don't even need a special training. You can just use the standard model for that.
No. You should do training yourself. Yeah, I was just saying how to get the training data. It was a synthetic data set that just you take all the
No, you have take real articles and take away the things everywhere.
The and yes.
Yeah.
And then ask the BERT to reconstruct them.
Yeah. So you mean that some special training will be needed, but this is feasible.
Yeah, this is more feasible than if you would train an LSTM or a transformer from scratch.
Mm-hmm. And for example, if I want to find all the misprints or typos in Russian text, orthographic error for склонение, спряжение, падежи.
That's a bit trickier because you have to produce a reasonably looking erroneous text with the wrong words used, word forms used.
No, this is easy to take from the internet, but then you don't have the correct version.
Correct. Yes.
Exactly.
Exactly.
Yeah. Alternatively, you can try to build like a model that predicts the correct words and just iterate over the different forms of the word and checks like the situation where the used word is way less common in terms of prediction than the one is.
That's one of the ideas also. Yeah, you can just iterate through all the forms and ask the language model for something that it was trained on, giving the language model score of the resulting text. Yes.
Yep, exactly. So like what is the probability of this particular like extension?
Yeah, it unfortunately creates a loop, a feedback loop, because if you start iterating the fifth word in the sentence, then the seventh word in the sentence, which may be in an incorrect form.
Yeah. Like yes, it helps with simple cases where you misprint one particular word. Yeah, if you if you use like the totally incorrect form, but like correct within its within internally, like you use, I don't know.
Yeah.
Then of course it will not work. But if you try to find like one misprint, it would work. Misprint, misspell, whatever.
Well, not quite, because suppose you have a sentence where only the seventh word is incorrect, in fact. but you don't know it. So you can try to start modifying the fifth word. And then somehow you modify it so it starts agreeing with the seventh incorrect word.
Yeah.
Not agreeing to something that, you know, the author
initially want to say yes.
Yeah, initially wanted to say, yeah, right.
Yeah,
That's very real. This situation is very real. I've seen it myself.
More or less, those are the things which I do manually sometimes, like when you're trying to. So it's not something that you can really avoid. It's not really clear. Should everything be aligned with the fifth word or seventh word? Sometimes, sometimes both texts make sense. Just have different meaning or something like this.
Yeah, you usually also bump into the limitation of the language model itself. You know, where you see something like that something agrees with something and is selected to be the correct one, but you look at it and you definitely see that this is not possible. Just the language model doesn't see it because, you know, it's not.
Yeah. Okay. So this is non-practical application. So what are the practical ones?
Yeah, the practical ones, the ones that we actually used or tried rather. First is the FAQ bot. And then the task we were trying to solve is that we have a FAQ, which is a set of answers for common questions. And for every answer, there is a few ways to ask the question that this answer answers. Like we had around 100 FAQ articles and 1,000 formulations of questions in total for everyone, for all the articles. We had a baseline model that just combines the word embeddings of all words and does a simple linear classification.
The setting is, so you have this training set, which are more or less correct answers to different ways of asking the question.
Exactly. Right.
And then you want to provide one of the given answer for a question asked by somebody else.
Yes.
Yeah. So you don't mean to create a new answer for new question. You just need to choose one of the answers for one of this for the
it's a classification problem. You get a question and you find which you have to answer which answers this question. So the baseline model that we used was a simple linear model over the bag of embeddings.
Can you say, for example, just one question and one answer, so we get some idea, for example, how long they are?
Well, the simplest answer is something like, we're located in Palo Alto, California. And the question for that would be, where are you located? What's your address? Where are you?
So the answers are more or less kind of
informational.
Yeah. So no, this is not possible. This should be popular.
Yeah. But that could be, could be an answer to any question.
Yeah.
Unfortunately, this is not possible yet. Okay. So what we did is we fine-tuned BERT to give a vector for each of the question, so that these vectors can be easily classified into the 100 answers for this particular FAQ file. And that gave us a substantially better quality of classification than the baseline model.
And quality is measured, you just hide some part of the data set from the model and check how it works. Or what?
Sure, exactly.
Yeah.
Well, of course, training LSTM from scratch or transformers from scratch would not give quality on a comparable scale at all, you know, because it's like 1,000 data points, and no neural network can train on that to a good quality. Fine-tuning BERT actually gave us a sensible increase in quality.
But very slow.
Unfortunately, yes, the baseline is extremely fast. It can hold like 1,000 queries per second on a single CPU thread. And launching that BERT model in production wasn't really possible. So that's, you know, half practical application.
Yeah.
Second is a part of a system of speech recognition. The speech recognition system outputs a text, which is a sequence of words written in lowercase letters, which is quite hard to read because people are accustomed to seeing sentences divided by dots, started with a capital letter, having commas in various places, etc. So we needed a system that would restore the punctuation and capitalization from the sequence of words. First, I created an LSTM model from scratch, trained it on texts from books, basically. Of course, by removing the punctuation, by lowercasing everything, and then trying to, at each point, trying to guess a label that has that states that this word should be capitalized, or this word should be followed by comma or dot or question mark. And then when I wanted to improve that, I fine-tuned a distal BERT model, which is a subvariant of BERT, that can also make a prediction at each word in the text. It gave us quite a reasonable quality improvement, but unfortunately, both models suffered from the fact that the speech that people use when they are not prepared for talking, like when they're not reading from a paper, like speaking in the online meeting, the grammar of these sentences is quite a lot different from the normal English grammar. People correct themselves, people repeat parts of the sentence. People don't usually, words and verbs and nouns don't usually agree with each other, etc.
Once I read the transcript of my talk about Kolmogorov complexity, and since then I try to avoid doing this. It was so terrible.
Talking or reading?
No, I was speaking, and then somebody for some reason make a transcript and send it to me for checking. But this was such a disaster that it's unbelievable how stupid it is.
Yes, yeah, and this is exactly why our model is not.
Yeah, there is a question.
Very good.
Is it feasible to do the inference on these BERT-like models on phones or computers without GPUs?
I'm not sure. I didn't actually check.
Not the learning, of course, but just the implementation.
As is, I think that would probably be quite slow, but not extremely slow.
No, but can you just keep the amount of data needed for that in a smartphone?
Oh, yes. BERT distal bird is like, I'm not sure, I don't remember the size of it. The original bird is like 100 million of parameters, which makes it, I think,
like 1
400
gigabyte.
400 million bytes, half a gigabyte. Distal bird is smaller on the order of magnitude, I think, smaller, or maybe half an order of magnitude.
Yeah. Okay. So in just what in fact it was used, this thing, or it turns out to be useless because of
the LSTM is in production at Kolibri.ai. The distal bird is in the process of being launched.
And can we see somewhere, just now go somewhere and check how it works, or there is no kind of demonstration like this?
No, you can create an account in Kolibri.ai and record some meeting. I'm not sure it's practical to do that right now.
Okay.
So another one is that one wasn't launched because it didn't really play well, but it showed promising results. So speech recognition is not 100% correct. In fact, it's a lot less than 100% correct. It's like 85% correct usually.
And so you want to run, after the speech recognition, you want to run this correction based on this text analysis.
Exactly.
But I thought that speech recognition already uses this kind of prediction probabilities to choose.
It does, of course. But the language model used in the speech recognition itself is a lot smaller than anything like BERT. We tried.
So to add the next layer of larger model.
Exactly. We tried inserting GPT-2 as the language model for speech recognition, and the result was a 10-fold slowdown of recognition. It was, or even less, even more, I think. Yeah. Maybe 50 times. Basically, currently we are at something like 20 times real time. Basically, we can recognize an hour-long conversation in 3 minutes, something. And with GPT-2, an hour-long conversation was recognized in 2 hours or something.
Yeah.
Otherwise, that wasn't feasible at all. So the language model is not capable, but when the texts are more or less stabilized, then running another language model is actually feasible. And we fine-tuned BERT that just says that this word does not belong here. It worked quite good, but it didn't really give us any hint what should be corrected for this word to be better.
So you find what is wrong, and that's all.
Yeah, and of course we find not all places that were wrong, and we found some places that were recognized correctly, but were regarded as wrong because of some other things, like the person was mistaken, or just the overall complexity of the sentence made BERT think that something is wrong here. So we dropped that idea and didn't really push it to production.
I actually think it could be useful as a kind of advanced spell checker. So if somebody tells me that something is wrong in my text, I can guess myself that it should be not vary but variate, or the other way around.
Yeah, just making some suspicious places, marking suspicious places would be a good idea. Yeah.
Yeah.
But actually, I think it's for practical reasons, it's kind of making subtitles for YouTube speech or something like this for conversations. So you need to do something fast or online. Just to
not only no. Actually, producing a readable text after the meeting is also very useful
idea.
Because many people actually need the transcript to write meeting notes, or remember what was said on the last meeting, or etc. It's still useful even after the meeting.
Yeah, and so following the idea of self-reference, I think this meeting is recorded, so just for fun you can try to put it through the system and send us what happens after that.
Okay, I can do that.
It would be interesting.
Yeah. Well, our speech recognition system is on par with Google's ASR quality-wise.
Okay, but just let's look where this on par happens.
Yeah, it's basically you usually it varies greatly with the quality of the of the sound quality and the general clearness of speech.
Yeah. That's interesting. Just how it works in practice, and all our incorrect English, what it will happen with it, and so on.
Sure. Just send me a file. I'll send you a transcript. So what? Thanks.
Yeah. So, but why, for example, we don't have the advanced spell checkers in I don't know, in LibreOffice, or we do have them?
We do have that in Google Documents.
But they are. Do you think that what we have in Google Docs is on modern, is what the modern technology could do, or it's some old and simple approximation which is not comparable with?
I'm not sure, but since it appeared quite recently, I think it's on modern technologies.
No,
there is also this thing called Grammarly.
Mm-hmm. No, I have to say that Google Docs indeed is useful. Sometimes they recommend to add the and and change something and so it's but I don't know whether it's correct or not, but I can only follow this recommendation.
But what do they use? They use also one of these models?
Maybe. I don't know.
No, it's not public, I guess.
Yeah, it's not public. And I don't work for Google anymore.
When I write email, they always correct not only my spelling mistakes, but also other mistakes. For example, when I write «одеть пальто», they correct «надеть пальто».
Wow.
That's great.
In Russian.
Fantastic.
Yeah, this is very good. Yeah. But to train such a network, actually, we usually need a corpus of feasible errors, which has stopped me from doing some model in 2018 or some 19 probably. I was actually trying to do that, but
so you need not only a correct text, but the error.
So do you see it?
Oh, this is great. Wow, I see, yeah. But I never experienced it myself.
But actually, they didn't correct «извиняюсь». I would say the more correct form would be «извините».
I'm not sure. I'm not sure actually. It's I believe it's like instead of одеть versus надеть, it's kind of normal now.
And if you write можно ли ей одеть пальто, what it will say? Можно ли ей?
It's correct. Можно ли ей?
Ну, вместо мне ей.
That's correct. Sorry. That's correct.
No.
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 And what they want?
No. Одеть is incorrect and послать incorrect. But everything else, it's correct.
But what they prefer instead of одеть?
You see? Do you see?
Yeah, we do.
And послать, послать. Oh, you see?
Yeah.
I'm not sure you can послать пальто anyway.
Yeah. And they will find this. You need this.
No,
but they don't understand that you need this hyphen.
Yes, of course.
You
But
cannot
also when other mistakes were fixed, the одеть пальто is now deemed correct.
Is now correct somehow.
Neural networks are complex things. You can't really understand what they're doing.
Yeah.
Maxim, can you show for a minute these Georges who are not the first president of the US?
Yeah, let me see.
I should warn you that we have only 3 minutes left. 3 minutes. In 3 minutes, we will stop.
Yeah, we can. Dewey, Marshall, and Wallace.
I'm not sure who George Dewey is.
I googled it. It's the only 5-star admiral in the United States Navy.
But he was George or not?
He was George, and Marshall is George Marshall, who gave the name to this Marshall Plan. And I need to find who is Wallace.
But you asked for Marshall or for George Marshall?
For George Marshall.
Oh, maybe there are some other George.
No, there are lots of Georges in the world.
No, but in general, I should say that today's examples were much less impressive than the last time promises. Either the modern technology is not still available for proletarian masses, or
as Segalovich, I think, put it, the future is here. It's not just evenly distributed yet.
And George Wallace participated 4 times in the elections of the president of the United States and failed every time.
Okay, cool.
Yeah.
So he wasn't the first
indeed,
president.
some presidents are important here.
And the US, of course.
Okay, so we have to finish. So thanks a lot, and indeed I'll try just look at the slides and try again this examples which probably are available. And also in terms of it's kind of a general announcement. We know Stas Sholunov, who was in Moscow University Logic Department at some point, and now he is a big entrepreneur in United States, asked whether somebody is interested in a programmer or kind of close to programming job in his company. And so if somebody is interested, I can send the reference.
But is it located in the US?
No, I think that the job can be remote, but the Sholunov definitely is located in the US. That's true. And it's not university. So there are also some university program and so on. And if people are interested, there are some. Sasha Golovnev also asked whether somebody is in need of something, and there are some announcements from other places which I get from time to time. So if somebody is interested, just tell, and maybe we can try to look
You
more specifically.
can somehow, there is a, I don't know, there is a mathematical logic department, and there are some groups and some social networks of it. Maybe there are some students that might be, I don't know, because
No, of course. If there are students whom you know and so on,
I mean, I don't know like any students, but I'm just.
No, that's what. No, if somebody of some participants of the seminar is interested, then I can tell him that, look, you should not miss this opportunity. But just for random students, they can apply. But yeah. Okay, so we'll think what will be next time. But we will try to, and where it will be, and how it will be called, and whether it will be a French Kolmogorov-Seminar or Russian Kolmogorov-Seminar or
Kolmogorov.
Kolmogorov. Yeah. Yeah, as they write. But so